Hi, welcome back. In this lesson, we are going to use a case to understand two-way ANOVA. Before using the case, let us understand the difference between one-way and two-way ANOVA. So, this is the case that we have used in the last sessions and this is the case that we are going to use in these sessions. In the last sessions, we are using this case, there were three varieties of wheats, okay, which are influencing the productions. So, what we have done, the seed wise productions we have seen, okay, this is the seed wise productions, and like seed A and B and C, this is the total production we have seen, and there is a mean, okay, mean of these, because these seeds were shown in 4 different lands and there is a mean value for this. So, obviously, there is a mean value for seed A, for seed B and for seed C. Whether there is a significant difference in the productions of seed A or seed A, B and C as far as mean value is concerned, we are just checking that in the previous lessons. In these lessons, what we are going to see, two-way ANOVA. Two-way ANOVA means that whereas in this way there is one factor that was influencing the productions. Here what we have taken two factors, varieties of fertilizers and varieties of seeds. In the previous case, we have taken the seeds in the column, and here in this case what we have done, we have taken fertilizer in the column. There are 4 types of fertilizers, that is W, X, Y, Z, okay, and 3 different types of seeds, that is A, B, C. There are 3 different types of seeds. So, there are 3 columns. This is column 1, this is column 2, this is column 3. Okay, we have we are going to see the mean value of column 1, column 2 and column 3, and we are going to compare whether there is a significance in mean value of the columns or not. What this column is all about? Column represents seeds, okay, 3 varieties of seeds, okay. And as far as row is concerned, row represents the fertilizers. There are 4 different types of fertilizers. There is a mean value for this. Whether there is a significant difference exists in the mean value of different columns or different varieties of fertilizers, that we are going to see. This is the case that we are going to see. Okay. The difference between one-way ANOVA and two-way ANOVA is that where one-way ANOVA, in case of one-way ANOVA, there is one factor that is influencing the dependent variable here, that is called productions. But in case of two-way ANOVA, there are 2 factors like variety of seeds and fertilizers, these are influencing the productions. Okay. Let us remember once again what we are going to see, that we are going to see the difference in mean in both the case. In case of first one, what we are checking, the mean difference we are checking this mean difference, this is row wise, okay. But here what we are going to see, this is both row wise and column wise we are going to see. So, obviously, for row wise there will be one null hypothesis and alternative hypothesis, and for column wise we will get also one alternative hypothesis and null hypothesis. For this we are going to get. So, this is exactly the case that we are going to use. So, this is the row, this is the row total is 16. We have just taken the sum of this 6 plus 5 plus 5, this is the 16. Similarly, this is 16, 9 and this is 19. This is called n. N means number of values. This is one value, okay. This is one value, this is second value, this is third value. Therefore, here it is n, means you can call it, this is Rn, okay. Row to Rn you can see, okay. N means number of samples, okay. That we, if you see the column wise, it is Rn, this is the Cn. Cn will be obviously, how much it will be? It is going to be, it is 1, 2, 3, 4. This is 4, we are going to use it, okay. So, this is the null hypothesis, this is the null hypothesis. Like all means concerning productions of varieties of seeds, seed is where? Seed is that is, this is column wise we have taken seeds. Okay. So this is all varieties concerning of seeds, concerning production of varieties of seeds are equal, whereas at least one of the means concerning uh, productions relating to varieties of seeds are not equal. Okay. So this is the for seeds wise difference we are going to see. For second one, we are going to see H1 all means concerning production of varieties of fertilizers, concerning varieties of fertilizers are equal. It has to like the all means productions concerning the varieties of fertilizer are equal. Here the at least one of the means of production concerning the varieties of fertilizers are not equal. This is a little that is we need to read like this. Okay. At least one of the means of production concerning the varieties of fertilizers are not equal, like that we have to read. Okay. So step 1 what? Step 1 is the correction factors. What is the correction factor? Correction factor formula is T square divided by 1. What is the T square? This total we have taken 16 plus 16 plus 9 plus 19. This is the T. Okay. This is the N we have found 3 3 3 3. So this is N. So we have got it. This is the first step that we have seen. Okay. Then this is the second step, total. Okay. Total is sum of all the values squares. Like there are how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have taken the square of all these values. That means 12 values are there in the columns, and we have taken the sum square of all the values and minus correction factors. So we have taken this 6 square plus 5 square plus 5 square plus 7 square plus 5 square plus 4 square plus 3 square plus 3 square plus 3 square plus 8 square plus 7 square, like that all the value squares have been taken, and these are summed up, and the value comes, this is SST, means sum of square total. Next step, earlier what we have done, we had done just the row wise that treatment we have seen, but here what, since two factors we have taken, both row wise and column wise we will take. Okay. So we have taken this, we have taken 24, what, this is the column, this is 24. Okay. We have taken the sum, this is 24, you can see this is the sum 24 we have seen. Okay. What is the number of sample? 1, 2, 3, 4, n equal to 4. So what we have in 24 by 4, 24 square by 4 plus 20 square by 4 plus 16 square by 4 we have taken, minus 300 is the correction factor. So the value comes, sum of square column total is 8. Okay. Next step is 4. Okay. So sum of square row treatment will be like, similarly we will do. So this is 16 square divided by 3. So we have taken, so there are 4 values here. Okay, we have also taken. Okay, 16 square divided by 3, 16 plus 16 squares divided by 3, 9 square divided by 3 plus 19 square divided by 3 we have taken. Okay. So minus correction factors, we have got the value, this has come, that this is row treatment, sum of square row treatment total. Then we will get the residual. Residual is the error, actually it is called. Okay. This is SST, means sum of square total, minus sum of square between columns plus sum of square between rows, like 32 minus 8 plus 18, we are getting it 6. Then we have got now correction factor, we have got sum of square total, we have got column treatment, sum of square column treatment we have got, row treatment we have got, residual we have got. Then we will prepare the ANOVA table. This is the ANOVA table. This is the column wise difference. Column, what we have taken in column? Seed. In rows we have taken the fertilizers. So these are the values we have put. So this is the column treatment, we have put it 8. Okay. This is the row treatment, this is 18 we have put. This is the error or residuals we have got it. Okay. This is the total of this. So degree of freedom for this is the column. For column degree of freedom, this is n equal to 4. 1, this is 1, 2, 3, 4. So therefore, this is the column, sorry, this is column 1, this is column 2, this is column 3. Okay, this is column 3. So therefore, what we have got, 3 minus 1 we have taken, because degree of freedom is calculated n minus 1, n equal to 3 minus 1 equal to 2. Okay. So, here it is 4 minus 1 because we have got 4 rows minus 1 it is 3. Okay. So, error we have similarly we have called degree of freedom row into degree of freedom columns. So, 3 into 2 equal to 6. This is degree of freedom row into degree of freedom columns. This is the 6 we have got. So, we have taken the mean square. What is the mean square? Mean square equal to, this is sum of square. Okay, sum of square values between the columns, it is 8 divided by degree of freedom. This is 4 we have got. Similarly, row we have got this 18 divided by 3 we have got 16. Okay. This is the residual. Residual means it is 6 divided by 6 we have got 1. Okay. So, now we will calculate the F value, that is F ratio, or this is actually calculated. Okay. This is mean square. Mean square is mean square divided by what? This is residual. Mean square is 4 here. Mean square you can see this is 4 divided by this is 1 residual. So, we are getting 4. Okay. So, for column fertilizers what we have got 6 divided by 1 we have got equal to 6. Okay. We have to calculate this is 6. So, now we have to, this is there is a alpha value we have been given, that is alpha equal to, or a level of significance we are getting it 0.05. This is table value for this we will get. So, degree of freedom F we have taken 2, this is the 2 we have taken. Okay. 2 for, we are checking here column wise difference. This is 2 and residual we have taken it as 6. So, we have taken, and this we have got it 5.14, we are referring to the table value. Okay. I will also show you the table. Then we are getting here, similarly we are getting here degree of freedom as 3 and 6 we are going to get. So, we will see. So, we now we have got the table value 4. Okay. This is the F value we have got, F calculated value it is 4, here it is 6. Okay. So, now we will compare the calculated and table value to understand whether the H0 is accepted or not. Let us see for this. So, we have taken this. Okay. We have taken this is the calculated, this is the calculated row wise calculations. So, we have got it, F calculated value is 4, here it is 6. This is the table value we have seen this, you can see. This is the 2, okay, degree of freedom and 6 error residual. So, we have got it 5.14, we have written here 5.14. Similarly, this is the like we have got it 3. So, degree of freedom 3, residual 6, this is 4.76 we have seen. So, now the thumb rule we have to refer here, the thumb rule, that is F calculated is, if F calculated is less than F tabulated, that means here F calculated, this is the case 1, this is the case 1, okay, case 1, if this is the case, then accept H0. If F calculated is less than F or equal to F tabulated, you accept H0. That means in case of columns means seeds, there is no significant difference between the productions concerning different seeds. Okay. So, whereas we are getting in the second case, this is the second case we have found. So, this is like F value, F calculated value is greater than. Okay. That means in one case what we are getting, we are accepting H0 in this case, whereas we are not accepting H0 in this case. Okay. This is actually we should correct it, all means of production concerning, this has to be, it has to be written like this, all means of productions concerning varieties of seeds are equal. Okay. This has to be read like this. So, this is the conclusion. Suppose we have to write in our research report, this has to be written. From the ANOVA table we find the difference concerning varieties of seeds are insignificant at alpha value 0.05, as the calculated F ratio of 4 is less than table value 5.10. But variety of differences concerning fertilizers are significant, as the F ratio, calculated F ratio 6 is greater than its table value. So, this is how we have to write in our research report. Okay, let us sum up what we have understood. So, in these lessons we have understood the difference between one way ANOVA and two way ANOVA. And in two way ANOVA, what happens? We have that added two more steps. In the earlier case, one way ANOVA, what we are doing, we were just calculating the mean value row wise, and we are trying to that find out the whether there is a significant difference in the mean value of the different rows we are trying to find out. But here in the two way ANOVA, what we are trying to find out, the both row value and both row and columns we are going to check. We have checked here. Okay. So that's for the lessons.